Here's a tutorial on how to conduct a 2x2 between subjects design in a factorial ANOVA. In this data set, we have 3 variables listed. The dependent variable is response time. This is a Stroop task where somebody's shown a color name, and that color name may be in the color that it's the name of, so yellow in yellow font, which would be congruent, one of our independent variables, or it may be in a different color, such as red, but the word says yellow, and you need to identify the color font, not the color word, and that is incongruent. And it is a well-established finding that congruent color word and color name are faster reaction times than incongruent. This study sought to see if standing or sitting led to a difference in being able to identify color font. So we have a 2x2 design. Participants were either standing or sitting. If you scroll down here, you see sit. And congruency was either congruent color name and color word or incongruent. Now, to conduct a between subjects factorial ANOVA, between subjects two-factor analysis of variance is another way to put that. We go to Analyze, General Linear Model, Univariate. Our fixed factors are our independent variables, so we have posture and congruency. Reaction time is our dependent variable, so we put that here in dependent variable. Now remember, it's always a good idea to get your descriptive statistics so you can see what is going on with your data. And if you click OK, then in your output, you see the number of participants in each of our 4 conditions. So we have standing, sitting, congruent, and incongruent, and there were 100 in each of those. This meant that when you combine them, there were 50 in each cell. So here's stand congruent, we have 50 participants, stand incongruent, 50, and then we have a marginal mean here telling us the mean for stand. Here we have sitting with the marginal mean here with the mean for sit. And then these are the marginal means for congruent and incongruent. And here is the grand mean for the total overall. Now, what we can see here is that posture was not significant, but congruency was. This is not surprising that congruency was significantly different, given that this is a longstanding finding in psychology. Now, for both posture congruency and for posture bicongruency, our degrees of freedom is 1 because these each have 2 groupings. There's 2 groupings for posture, 2 for congruency. And then when we're looking at the main effect, the degree of freedom is n minus 1. So 2 minus 1 is 1. When we're looking at the interaction, you multiply the degrees of freedom from the main effects that are involved in the interaction, and here 1 times 1 equals 1. So as long as you never go above 2 groupings or 2 levels, your degrees of freedom 1 will always be 1 for both main effects and interaction effects. And our degrees of freedom for participants is what's shown in the error row here for 196. As you can see, there is no significant interaction and no effect for posture. But let's look at what a graph would look like. So there's a couple ways you can do the graph. Here's one. You go to General Linear Model, Univariate, and you can go to Plots and click the factors into these boxes. You can do a line chart or a bar chart. Click standard error. You want to have 1 standard error. Click OK, OK. And here we have the same thing again, although now we can see that there seems to be a little bit bigger difference with sit than with stand. Now, if we had a significant interaction, I'm going to show you how we would follow that up to look at simple effects. So what I recommend doing is to go to Data, Split File. We're going to split up posture between stand and sit. And then we're going to conduct that same test, but we're taking posture out of it. So here is our findings with the variable stand. Congruency is significant. And here is our finding with the variable sit. Congruency is significant. Another way we can look at that is data split file, posture goes back. Now we're going to divide looking at congruent and incongruent. Analyze. Now we're looking at the effects of posture within congruent and incongruent. When it's incongruent, meaning the color name and color word are not the same, then they're not significantly different. And also we can see that when it's congruent, they're not significantly different. This is not surprising though, because we did not have a significant interaction. So another way to make a graph is to go to graph, bar. We want clustered because we're dealing with two independent variables. We're doing between subjects, so we want groups of cases, define. And the bars represent, this is where our dependent variable goes, reaction time. Category access will be posture, congruency will be define cluster. You could swap these around depending on what is the best way to communicate your findings. Click display error bars, standard error 1, continue, okay. And I just realized I still have them split, so let's unsplit that file. And do that again. Go back to graphs, bar, and everything should be set up fine. Okay. Well, why won't it unsplit? Analyze. Oh, I forgot to click analyze all cases. There you go. And one more time. Third time's the charm. Graphs, clusters, everything. Yay, it works. So here you can definitely see by looking at the error bars and the means that there is a difference between congruent and incongruent, but there really does not seem to be a difference between standing and sitting.